welcome to Asian Teachers Maths. Today let's talk about fraction. So this is a fraction. It's read as 3 over 5. So the one on top is numerator and the one in the bottom is denominator. So this is equivalent to 3 is divided by 5. So, then why don't we just use division? Why we're using fraction? Actually, using fraction is the preferred way. We rarely use division. So let's see what does fraction do. So this is a full circle, or you can imagine it as a pizza. So this has a value of 1. The shaded region is the value. This is a 1. And on the right, we divided the pizza into 5 equal fractions, as shown in the 5 here. The 5 at the bottom, or the denominator, means how much equal fractions are we dividing the pizza. And the 3 here, the denominator, means how much fractions are we taking. So we're taking 3 fractions. And this is the shaded region will be the value. And you can see 3 over 5 is smaller than 1 because these are not taken. Okay. So this is what fraction is. And if we look at another pizza, so in here, this is another pizza. This is divided into 8 equal fractions because the denominator said 8. And then we are taking 3 fractions of it because the denominator said so. So this is a 3 over 8. Okay. A decent portion of the pizza. Yeah. And what if we want the whole pizza? In this sense, we can take 8 over 8. Okay. Which means this is the full pizza, which is a 1, right? And yes, 8 over 8 is a 1. If you look at the division, eight is divided by 8. So it's asking 8 multiplied by how many is 8? Is 1. Or we can take 8 marbles and do the divide into 8 equal portions and take 1 portion thing, and you still get 1. So, and also this is also true for this pizza. This pizza is divided into 5 equal portions. But what if we want a 1 back? We take 5 portions, right? Or 5 fractions. So imagine all of this is straight. Then we have 5 over 5. 5 divided by 5 is equals to 5 over 5. And is equals to 1. Okay. Then let's look at another situation. What if we are doing 7 over 5? Okay. So 1 piece will be enough because let's say we divide into 5 equal portions. Then we are taking 7, but there's only 5 here. So we need 1 more piece or more pieces. Then also divide by into 5 equal fractions and take 2 more because we already have 5. So we take 2 more and then we get 7. So we have 7 over 5 here. Both of these together, added together, is 7 over 5. So this is also known as 1 and 2 over 5. So this is 1, this is 2 over 5. This is another form to express 7 over 5. In most situations, the upper form will be more useful. And sometimes this will appear, but rarely. Okay. And another interesting property of fraction is that we can expand it without changing its value. What do I mean? So in here, this is a pizza cut into 10 equal fractions, and we are taking 6 of them. Oh, you can see this pizza has the same value as this 315. Okay. And what happened here? So if we multiply 315 by 2 over 2, or let's say we are multiplying 3 over 5, multiply the numerator by 2, we also multiply the denominator by 2. Okay. This is equivalent to multiplying 3 over 5 by 2 over 2. So this is a 1, because this is 2 divided by 2. Then we have 6 over 10. Okay, from here to here. So we have 6 over 10. And you see they will be equal to each other because I have just multiplied by 1. So when the denominator and the numerator is multiplied by the same amount, we will get back the same value. And how does this make sense in the role of fraction? So let's say this is 5 equal portion. Then I have 3 of them shaded. So this is a 3 over 5. Then I turn it into a 10 fraction pizza. So I divide each portion into half. Now I have 10 fractions. And you can see 6 of them are colored. 6 of them are colored. So this is the same fraction. At least the value is the same. The fraction is not exactly the same, but the value they represent are the same. And you can see here, similarly for 9 over 15, we multiplied both the numerator and the denominator of 3 over 5 by 3. So then 3 times 3 is 9, 5 times 3 is 15. And it is still the same value. Okay. Since we can expand a fraction, which means we can also simplify a fraction. So let's say I have a 6 over 10 here. Oh, can I write it? Can I express the same value using smaller numbers? Oh, we can, because we know these two have the same value. So then we divide both the numerator and the denominator by a common factor. We should be doing 2 here. So then 6 divided by 2 will be 3. And 10 divided by 2 will be 5. And we get the simplified version of the 6 over 10. And when we are doing calculation, it's recommended to use the simplified version as the final answer. You can use this, of course, during the calculation, but during the last step, when we are giving the answer, we should be using the simplest form of the fraction. Okay. And next, let's look at this situation. This is a 1 over 3. Okay, this pizza has 3 equal fractions. This is a 2 over 5. These pizzas have 5 equal fractions. And which one is more pizza? Okay. Let's say they're on the same price in the pizzeria. Then we're like, oh, which one should we buy? If we want the more one, although they have different flavor, but let's say they, yeah. So which one has more pizza? Yeah. It's hard to tell, although from comparison or from observation, this one seems to be slightly larger. But how do we show them on paper that this one is larger than this one? How to compare? If we were comparing pieces with the same denominator, it will be very straightforward, right? Because this is 3, this is an 8 portion, it's 3 portion, and that portion have the same amount. Each fraction has same size. So then we know that, oh, this is definitely more than this one. Okay. But how about here? Oh, remember we can expand or simplify the fraction. Okay. So if they have the same denominator, then we can compare. Like here. So let's transform these fractions into fractions that have the same denominator without changing the value of the fraction. Okay, so 3 and 5, their common multiples will be like 15 and 30. So let's use 15 because it is smaller. So in here we have 1 over 3, and then turn it into a fraction with the denominator 15. So I have to multiply by 5 over 5. Then I have 5 over 15. Okay, this is 1. Then how about the 2 over 5? I want to turn this fraction into a fraction with the denominator 15. So I will multiply both the denominator and the denominator by 3. So I am essentially multiplying by 1, which does not change the value. Then I have 15 as the denominator and 6 as the denominator. Oh, as you can see, if they are both in the pieces with 15 equal fractions, the 2 over 5 will be 6 fractions of that, and the 1 over 3 will be 5 fractions of that. Oh, then we know that the 2 over 5 is larger than 1 over 3. Okay. Next, what if we try to do some addition and subtraction with the fractions? So let's say we're doing 2/6 adding 3/6. It's like positive 2/6. This is positive 3/6. And what would that be equal to? Okay. So they are on the same piecer. Because, okay, this is... So divide into 6 equal portions. Okay, almost equal, okay. So this is 2/6. And this is 3/6. Then this will be 5/6. And we have 5/6. Okay. So we can do this directly because they are on the same pieces, and these pieces has each is divided into 6 equal fractions. And on the next day, let's say we want to do some subtraction, but this time with fractions of different denominator. Let's say this one. So this is a 2/4, positive 2/4, and a negative 4/6. So it's like, okay, we are working at the pizzeria. We have 2/4 of this pizza, and the customer is ordering 4/6, and we don't have enough, right? So in the end, we will be at a deficit of this part, right? Because we can fulfill this part, but we cannot fulfill this part yet. So we have to make more pizza. But how much is this part? So the answer will be negative number because we are at a deficit. And how much is this? So they are not on the same pizza because this is 4 fractions. This is 6 fractions of the pizza. So first we have to transform the fractions into fractions that have this common denominator. Okay. So 4 and 6. The common multiples will be something like 12 of 24. 12 will be smaller, so let's use 12. Then, okay, 2/4 minus 4/6 will be equal to, okay, 4 times 3 will be 12. 2 times 3, such that we are multiplying the same number on both the denominator and the denominator. Minus 4 times how many? Let's work denominator first. 6 times how many is 12? 2. We want 12 as the common denominator. So this is 4 times 3 then. Okay. And this will give us 6/12 minus, oh, this is 2, sorry, because we have to multiply the same number on the denominator and the denominator. This will be 8/12. Okay. And this will give us 6 minus 8 will be a negative 2. So this will be negative 2 over 12. And then it will be a negative 2 over 12. Because if one of the denominator or denominator is negative and the other one is positive, then we have a negative number. So this is negative 2 over 12. But we are not done, because this is not the simplest form of this fraction. For 2 over 12, it can get simpler, because if we divide both the numerator and denominator by 2, then we have 1 over 6 negative. 2 divided by 2 is 1. 12 divided by 2 is 6. Okay. So we have final answer here to here is negative 1 over 6. Okay. This is how we do this kind of addition or subtraction. And finally, let's talk about this one. The lower half. So remember we talk about dividing by something is actually multiply the inverse of it. Okay. So this is 8 is divided by 4. So if we do the division, it's 8 marbles. So we divide into 4 equal portion, 1, 2, 3, 4, and take one of them. I'll get 2. Okay. And this will be equals to 8 times the inverse of 4. So this 4, you can regard as having a denominator of 1, because 4 divided by 1 is still 4. So if we express 4 in a fraction form, it's 4 over 1. Then 1 over 4 will be the inverse of it. Okay, it's like the numerator and denominator changed places. Okay. So, and why is that? Why are these two equal? So one way to look at this is 8 times a quarter. What does that mean? So 8 times 2 is counting 8 2 times. So positive 8, then we have positive 16. And for multiplying a quarter, so which means we're counting 8 only a quarter. I'm counting less than 1 of 8. This is 1 time. A quarter is less than 1 time. So this is a quarter of time. I'm only counting 8 a quarter of time. So of course I'll get 2. So that's why I can do this conversion. And and the order of multiplication doesn't matter too, right? So which means this will also be equals to 1 over 4 times 8. And it will be, okay, counting a quarter 8 times. Is this still 2? And why is that? So when we look at here, we can imagine like, okay, these 8 marbles, we're only looking at a quarter of them individually, and all of them are only looking at their quarter, and we are multiplying by 8 times. We are counting their quarter by 8 times. We also get a 2 after we get the 8 quarters, and then we like piece them up together again. We will also get a 2. Okay. So this is why, okay, 8 divided by 4 is equals to 8 over 4. Okay. They're the same thing. Okay. So this is for today. Okay. Next we will tutorial and also ratios.